And can everybody see the screen share? I'm going to try and bring up the chat here. So if anybody has a question, you can go ahead and throw it in the chat and I'll try to. Oh, excellent. Good deal. So, all right, you're building cloud ready apps. My name is Dustin. I'm an application architect at a company called 3Cloud. And it says 3Cloud, so you kind of expect that we do all the clouds, but we don't. We only do Azure, but we do it really well. 3Cloud is the top Azure partner in the country, win all sorts of awards, but we are all about Azure all the time. This talk is not Azure specific, so don't worry about that if you're a big fan of the AWS or the Google or one of the 8,000 other cloud providers, or if you're not in the cloud at all, also totally cool. If you want to learn more about me, you can check out my website and LinkedIn. I occasionally post on there as well. So a lot of companies are either going to be building in the cloud soon or they are already. We talked a little bit earlier and before the recording about kind of hybrid situations. So a lot of companies are either thinking about or going to the cloud, or if you're DHH and you work for Basecamp, you're leaving the cloud. Also, something that some companies end up doing over time. Their cloud investments turn out to be not as good as they thought they'd be, so they leave the cloud. But the thing is, you don't necessarily have to go to the cloud to be able to build apps that run well in the cloud. So you can build applications that have a handful of these design principles that we're going to talk about, and they're going to run well anywhere. They're going to run well in your data center. They're going to run well in the cloud. When you get tired of the cloud, the public cloud, you can come back and they'll run well in your data center again when you get fed up with it, and then you can write snarky blog articles about cloud providers like DHH. But that's the purpose of the talk today. We're going to talk about building things that are viable in the cloud. As far as my experience goes, I have been doing cloud architecture for the past 5-ish years. I've worked with a variety of different clients, building a variety of different things in the cloud. Some of them have been microservice related, some healthcare, various industries. So I've helped a good chunk of companies and talked to a fair number of people about building applications in the cloud. And this is going to be a combination of that experience plus a lot of research and other resources and other smart people that have documented their journeys to the cloud and different patterns and practices that are going to help you as well. So our flight plan for today, we're going to talk about what it means to be in the cloud and what it means to build an application that's cloud ready. We're going to answer the question of why should I care, why bother? And then we're going to talk about code patterns. We're going to move up to architectural patterns, and then we're going to cap it off with some DevOps tips. And if you have any questions, either fire up the microphone or throw them in the chat, and I'll try to answer them as we go along. Otherwise, if you don't want to do that, we can also talk at the end. If you have questions, you want to wait till the end. Does that make sense to everybody? All right. All right. Let's go. All right. So, first question. What the heck is the cloud? We tend to bandy this term about a lot, especially as architects. There's a lot of talk about the cloud. And usually when we say the cloud, we usually mean some sort of public cloud. A lot of times we talk about, Azure, AWS, or Google, one of the biggies, or one of the many other public cloud providers. But the reality is that the cloud is less of a product offered by a big company and more of a set of capabilities. Those capabilities being on-demand self-service, so the ability for people to provision their own infrastructure, preferably through some sort of code. Rapid elasticity, so the ability to scale up and also importantly scale down your resources according to demand. Having a pool of shared resources, so having a large set of servers for your whole company, or in the case of public providers for a large number of companies that you can then dole out small chunks of via metered usage. So basically doling out your infrastructure with some sort of resource constraint or metering, and then having that accessible over the network. And the upshot of this is that the cloud can come in several different flavors. So obviously you have your public clouds, but you also have private clouds. So if you have your air-gapped installation, for example, you can still get all of the benefits of the cloud without going to Azure. Well, you can get like 90% of the benefits of the cloud. You're still a little bit limited because your data center isn't going to have as many regions or servers as Microsoft's data center, but if you're a bigger company, you can still get a lot of benefit. So there are specific private cloud products by most of the major cloud manufacturers. I know of like Azure Arc or AWS Outpost. And then there's also a large series of hybrid clouds. So you have things like OpenStack, you have Red Hat OpenShift, which is a Kubernetes distribution. There are lots of other Kubernetes distributions, or you could use something like Pivotal Cloud Foundry. And the nice thing about these hybrid solutions is that you can run them in your data center, or alternatively, you can run them in the cloud, or you can run them in both places and move things up from your, data center capacity up to publicly, access cloud capacity. So you have a lot of, different options as to what counts as the cloud. The point is that instead of it being Azure or AWS or whatever, it's really this set of capabilities. And so why should we build applications that run, cloud-ready applications? Why bother? Why is this an important topic? Well, one, if you can run well in the cloud, you can run well everywhere. Applications that run in the cloud or that are built to run in the cloud are going to run better even if you never go to the cloud. They're going to be easier to scale, they're going to be more maintainable, generally they're going to be more modern, they're also going to be easier to evolve down the road. And the thing is, we're going to go through a lot of concepts in this talk, and you're probably going to think of, some of this is like, how is this cloud ready? But the reality is there's a lot of overlap between what constitute a good app, quote unquote, and something that is cloud ready. So there are specific patterns that make your application more viable in the cloud, but most of those are things that you probably should be doing anyway. And so with that, I want to talk a little bit about cloud migration. So the assumption here is you have something on the ground, you want to get it into the cloud. And there are 5 different cloud migration patterns that all handily start with the letter R, very convenient for alliteration. The first one's going to be your classic lift and shift, which is easy to do, but really doesn't give you any of the cloud advantages. You're almost not even in the cloud. Like you're just renting a VM from, you're basically renting an expensive VM if you do a lift and shift. The second pattern is you're going to be refactoring. So this is where you take your application, you swap out some config files, you change a few things, and then you can drop that into a PaaS service or containers. Re-architecture is a little bit more involved. This is where you take an application that's maybe a little older, and then you break it down and you re-architect it into a cloud native format. So an example of this would be a monolith to microservices conversion. So you take a big legacy monolith, you start stripping off services, you put those services in containers, you run them in something like AKS or EKS, or one of the many container services, and then you build like an abstraction to in front of that to put a facade in front of it, and you start choking out the old code via something like the strangler pattern. That'll be an example of a re-architecture. If your application is too old and you don't want to move it, you can also do a total rebuild and rewrite the thing from scratch. Not ideal, obviously, but some things are just old and need to be rewritten. And then finally, the easiest of the cloud migration patterns is to not migrate it to the cloud at all and retire it and shut it down. And the thing is, each of these has a different cost to migrate and a cost to run. For example, your lift and shift is cheap to do, but it's more expensive in the long run in terms of your run costs. The refactor, re-architect, rebuild are all increasingly expensive, but at the end, you have a cloud native application and they're all going to be similar to run. Though you could argue that some of these might be more expensive just because it's older code that might be less optimized, but overall, they're going to be roughly similar. Our goal as cloud-ready app builders is to get it to the refactor point. This is where we want to be. So we want to build an application that is easy to lightly refactor and then put in cloud hosting, whether that's PaaS, whether that's container hosting, whether that's easily decomposing it into a function app or Lambda, all of which are valid strategies for migration. So that's where we want to be. And in order to do that, there are different things we can do to make our applications run better and be more cloud compatible. And what we're going to start off with is we're going to start off with code patterns. So these are things at the coding level that we can do to make our apps better at running in the cloud. And the first one is something that you should probably be doing anyway. This definitely falls under you should be doing it anyway, and that is using dependency injection. So, in your application, this comes for free in the .NET framework now, or in the .NET, in ASP.NET Core or ASP.NET Core. This is something that you should be doing. Specifically, you want to be abstracting away your infrastructure dependencies. So things like anything that touches a local file system, anything that touches a messaging system, anything that touches any kind of other like resource that could theoretically be later swapped for a cloud version of that resource. You also want to be abstracting any kind of calls to outside services as well. You want to have those all behind an abstraction because you want them to be easier to swap out later. If you want to go a step further, you can actually just straight up dependency inject your infrastructure using a tool like Dapper. So Dapper is a distributed app runtime where you can create, you basically run a container. That container acts as a sidecar to your application, and you configure your infrastructure dependencies via Dapper, and it runs them in containers, and then your application will access that using HTTP. And what's cool about Dapper is you don't actually have to change your code at all hardly in order to use it. You just change your configuration. So you can start off local, and let's say you want to talk to like a Redis cache. Locally, you can just set up a local easy Redis cache, but when you go up to your hosting provider, you can actually talk to like an Azure cache for Redis. Probably more importantly, if you're doing like messaging, for example, in Dapper, you can set up local code that talks to just Redis or some other backing store that's really basic. And then when you go up to the cloud, you can talk to something a little bit more advanced, like an Azure Service Bus or whatever the Amazon equivalent of an Azure Service Bus is. And so you can actually have code that looks very similar, and you don't even have to dependency inject your code. You can change it at the configuration level. So Dapper is really cool, but it does require a little bit more involvement than you don't get Dapper for free. There's some design constraints with using it, but pretty much anybody can use just good old-fashioned dependency injection. Configuration. In the cloud world, we tend to prefer our configuration to be stored in environment variables. This is kind of a departure from the standard .NET practice of using those configurable JSON files. A big part of the reason for this is because when you're running applications in the cloud, you tend to use kind of disposable infrastructure, and it's easier to change the configuration of your container that's running your code rather than having to rebuild your application to get another config file out the door with your CI/CD. This again is built into the .NET, into ASP.NET Core. So environment providers are part of your default stack of config providers. So this doesn't really cost you anything either. So, and also for local development, you don't need to use environment variables for that. Make sure you use your local secrets. Another advantage of using the environment variables in your local secrets is that keeps your configuration information out of your Git repos, so you don't have a chance of accidentally committing sensitive information to Git, which, depending on what provider for your source control you use, might get you on the naughty list. Statelessness. Avoid any kind of stateful app. When I first started doing development, we always had this assumption that we kind of started with like in-memory state in our application, and then over time that has kind of become a non-standard practice. But as a general rule, you want to avoid any kind of statefulness. So you want your services to be, gets a request from the user, hydrates whatever data they need, does the processing, sends them back. You don't want to have any kind of sessions or local caching in them. So specifically in the .NET world, we want to prefer the distributed cache over memcache. That's the big one there with statelessness. Because ultimately holding stuff in state really hinders the scalability and flexibility of your app. even if you have a load balancer that it has like sticky sessions, it's still going to be less optimal than not having to have sticky sessions and just having all of your downstream providers of stuff be able to return that request. Make sure you build in resiliency. One of the things about the cloud is whereas the cloud has a high level of availability, it's more like high level cosmically, not necessarily high level individually. The cloud is kind of like this ecosystem where collectively it is strong, but individually it is less so. So when you're building applications that run in the cloud, you want to build in resiliency patterns so that when you're making requests, if they come back with a transient failure, you have retry logic built into those so that you can basically rerun those requests as needed. But it's not simply retries. There's a whole bunch of different patterns. The .NET library that's kind of the default for this sort of thing is called Poly. And Poly is, I've used it in a couple projects and it's pretty good. So what we're going to do is I'm going to walk through a couple of different patterns. And kind of the name of the game here is that this isn't something you want to apply at a kind of a blanket level. You want to be really selective because every one of these resiliency patterns kind of has like a, if you do it wrong or if you configure it incorrectly or if you overdo it, you can shoot yourself in the foot. So you want to be careful with these. So the first one's going to be your classic retry. So a lot of times if it's just a blip, you can retry again. The problem with retry is that you need to have some things in place so that you don't retry constantly. So if you just have infinite retry, there may be a situation where just things are down. Or alternatively, if you have retries that happen like every second, for example, that retry might just, you have a whole bunch of things sort of stack up on a server or a service, you might end up in a retry storm where all of the apps that are calling that service are just trying over and over and over again. So a couple of things, one thing you can do is you can implement something called an exponential backoff. And this is where you call, maybe do a fast follow. So, retry once, and then every time you retry again, you're going to have an exponential amount of time. So, like, let's say 250 milliseconds, then 500 milliseconds, then wait a second. And then after that, maybe you just don't retry anymore. It's also good to throw in a little bit of randomness to your retry strategy. So having like 150 plus, 1 to 1, somewhere a random 0 to 100 milliseconds. Because what you don't want to do is have a bunch of different services retrying all at the same time. So add in a little bit of randomness on your retries to make it easier to, not happening all at the same time. Also, consider implementing a circuit breaker. So at some point, if you're hitting the system over and over again and it's broken, maybe it's broken for real, and you need to just fail the call and let it go and let that system heal. So this is especially true when you're getting faults due to performance issues. I remember working in a system where we were using Poly and there were a lot of retries, but the underlying system was just not very performant. So you ended up shooting yourself in the foot with a lot of retry logic, and we kind of had to scale that back in order to preserve the integrity of the underlying system. Another resiliency pattern is to use cache, but as we all know, cache is an architectural trade-off where you're basically adding complexity but gaining performance and some level of resiliency. But as we all know, there are two hard things in computer science: cache invalidation, naming things, and off by one errors. Another resiliency pattern is bulkhead isolation. So basically, this is where you constrain your application. So if something blows up, it doesn't blow up your whole application. Fallback. So if you have something that's failing and your retry isn't working, instead of just exploding, make sure you have a graceful, fallback strategy. This will make your application more performant in the long run. So all these things can be mixed and matched, and you can end up with a really complex flow depending on what you're doing. But I would recommend starting light and then sort of evolving your application as you go on. Like, you don't need to throw the book at every request. Another thing you need to do is you need to design your application to be performant. We'll walk through a few performance patterns as well. But the reason we want to make performant applications is because time is money in the cloud. One of the advantages slash disadvantages of having a metered connection in Azure and having auto scaling resources, or not Azure, but in the cloud in general, is that when you're in the cloud, you can actually tightly scale your resource consumption, your consumption of compute resources to what your application actually demands. Specifically, the scaling down of resources, which is where the money's at, and scaling things down during times of lower demand. Whereas on-prem, you kind of have your scaling is more of a step function. So you add another machine, and that gives you a lot more capacity, but that capacity can get, you're going to have that spare capacity while you're having your application eaten, having your application, you can be inefficient. It allows you to be inefficient. Whereas in the cloud, time is really money. So a couple of different patterns to think about are, when we're going to talk about anti-patterns, is going to be, there's a couple that go with the database. The first one's going to be called busy database. And so this is where you kind of treat your database as a service. You see this a lot in legacy applications where you put all of your business logic in the stored procedures, and you're treating your database as more of a compute function than a data store. And this is not ideal in the cloud world because a lot of cloud databases are have like very specific resources, resourcing via or resource meters. In Azure, we have DTUs or data transfer units. And so you're going to end up eating a lot of DTUs doing things that probably would have been better done in your application. Things like formatting, structuring business logic, that sort of thing. Another database problem that you run into is called chatty IO. So this is where you have a lot of small requests for data that can overwhelm a database, especially if you have overhead on all those requests for the connection management and the network and all of that. So generally speaking, you want to like have a smaller number of larger requests. But what you don't want to do is you can also go too far and fetch too much data, which is extraneous fetching. Honestly, in terms of performance mediation, I've been burned more by extraneous fetching than chatty IO personally, but I don't know if your mileage may vary. You kind of have to shoot the middle with this one and try and get in between having too many small calls or just one gigantic call that pulls back a bunch of unnecessary data. Make sure you use your async and await keywords and try to keep everything as asynchronous as possible. Specifically, your HTTP requests and any kind of data access. Those things are going to tie up your threads and tie up your resources while waiting for stuff to come back. And it's just generally a good practice to always be asyncing those sorts of things in your code. I've gotten huge mileage in performance mediation just by implementing async. I had an instance where we had an application that we were migrating to the cloud. It took several days to run a particular actuarial process and then blew up production. And between simple performance mediation, like reducing your database calls and stuff and asyncing them, we got a process that took multiple hours to run that blew up the production database to run in about 15 minutes. So I felt, and a lot of that was, putting it in the cloud and having scalable resources, but even more of that was, just simple things like optimizing your database calls, making sure everything is asynchronously called and just generally being mindful of compute. Specifically, another thing for performance is being mindful of logs. You only want to log what you need. You don't want to log a lot of extraneous data. And so in your different environments, you want to be very conscious of what you're logging, especially in the cloud, because every gigabyte counts in terms of money. Like it's a real easy source of cost overruns to have a lot of extraneous logging. This can happen on-prem too if you're using a tool like Splunk or another log aggregator. You can definitely have cost overruns by not controlling your logging. So especially in production, you don't want to be using verbose logging. Keep your verbose logging to your lower environments that have a lower volume of data and where you're going to be doing most of your troubleshooting anyway. And so with that, that covers our code patterns. And I'm going to kind of move up a level of abstraction and talk a little bit more about architectural patterns. The first one, similar to dependency injection, is isolating your dependencies. There's a whole bunch of different names for this type of architecture. So people have called it hexagonal, clean architecture, onion architecture. There's probably at least 5 other names for this, but it all kind of boils down to the same concept. The way you want to structure your applications is you want to have your domain logic and your domain model, aka your business logic. You want that to be in the center of your application. And that needs to be relatively pure and not have any hard dependencies to anything outside of itself. So your business logic needs to have the proper level of abstractions and dependency injection in order to be pure and clean. It also makes it a lot easier to test. Outside of that, you have your application layer, and then on the outside of the onion or the hexagon or whatever you're doing, you want to have your dependencies to your frameworks, to your external services, to your infrastructure, to your data stores, et cetera, on the outside of your application. And that way, when you swap these things out, you don't have to change any of your domain services or business logic or anything in the middle of that. Another kind of architectural thing, and this is a bit of a history lesson, is something called the 12-factor app framework. A lot of people, especially when I was beginning to do cloud migration projects, talked a lot about the 12-factor app. And the 12-factor app framework is a list of principles created by a company called Heroku. And if you're a .NET developer and you've been a .NET developer for a long time, Heroku might be an unfamiliar name to you, but Heroku is a company that was one of the first providers of what was later called a PaaS service. So they started with Ruby on Rails, and then they were really popular with Node as well. And eventually Heroku was bought by one of the larger companies and sort of absorbed into their operations. But Heroku published a list of principles called the 12-factor app framework. And these 12 principles are different ways of building an application that run well in the cloud. And you'll see them, you'll notice that a lot of the concepts that we talk about here, many of them are represented on this list. That being said, the 12-factor app framework is a little old, and there's a lot of things on this list that are really obvious or things that we just kind of do by default. For example, the first 12-factor app principle is use source control, which that seems to be pretty much table stakes. I don't think I've had to tell anybody they need to use source control pretty much ever. So I don't think that's a real uphill battle in our organizations. But one of the things about the 12-factor app framework is that a lot of times the idea is that this is something that's related to microservices. And there's this kind of debate about microservices and monoliths, and whether if you want to be a proper cloud application, you have to be in a microservices format. And the reality is you don't. Microservices are good and they're fine and they run well in the cloud, but so do monoliths. So you can have a cloud native monolith that's awesome and runs great, and you can have microservices that don't run well in the cloud at all, though it is a lot harder to run microservices without cloud infrastructure. And something that we need to remember about the whole monoliths versus microservices debate is that the reason we have microservices is not because they're some sort of magic architecture thing that are amazing. It's because of Conway's law. So Conway's law is this idea that your organizational structure influences your architecture. And the thing about microservices is they were invented specifically in larger companies where you wanted to have a team be in charge of a single unit that they could have, they could have the full life cycle. So they didn't have to be dependent on outside teams to evolve this particular piece of code. So microservices make a lot of sense when you have a very large team and each team gets its own domain scope chunk of the app to manage. Microservices make less sense in teams that are, if you have like 5 people, you don't necessarily need to have a microservices architecture. And as far as cloud readiness goes, it's not relevant at all. And in terms of Conway's law, you know, again, your structure of your team structure is going to determine your structure of code. So if you do like horizontal slices, so like front end, middleware, back end, you're going to have 3 different services in 3 different areas of the code. More ideally speaking, you want to have those divided into business functions, then you have vertical services. Another concept with the cloud, another little bit of history, is you want to really structure your code in terms of building it into APIs. And again, this isn't necessarily a monolith versus microservices thing. In your monolith, you can have a monolithic API, and you can use that to power your monolithic UI, and that's totally fine. Or you can build microservices and have your API structured that way. But this right here is a little bit of a clip from something called Steve Yegi's platform rant, which I'm going to include the slides. It is worth looking up and reading because it's absolutely hilarious. But this particular rant is a series, is a paper written by a guy named Steve Yegi who worked for Amazon when they started building their services-oriented architecture, then moved on to working at Google. And kind of the upshot is that Google did everything right versus Amazon, but Amazon mastered APIs, and because they mastered the API, building their stuff as APIs, they were able to create all this extensibility. They were able to create a situation that overcame all of these other deficiencies just because they mastered the API. And I'm not going to read these to you, but I'll give you a few seconds to read these slides.
Dustin, are you going to post these slides somewhere?
Absolutely. I'll throw them up on. I'll probably throw them up on SlideShare, and then I will. I'll send a message to Robert, and he can share the slides.
Thank you.
And a lot of the slides also have notes and links in the notes section too, so you'll have reference as well.
And once I get these, usually what I do is I put them in a comment for the session, the meetup session. So you just go to Meetup and you'll find the slides and the video link in a comment.
All right,
Awesome.
good deal.
Thank you.
Yep. And so there are a couple of different advantages to using APIs. The big one is it keeps your major components loosely coupled. So loose coupling is good for evolutionary architecture. It's just good in general. APIs also enable platforms, so you can have internal platforms where specific pieces of functionality can be reused, or eventually you can also have external platforms. A lot of the power in certain larger products, like Amazon, for example, is having these external APIs that you can expose to other developers. And if you build as APIs from the beginning, all you really need to do is slap an API gateway in front of your existing APIs, set up your resource constraints and limits, and then you can expose that publicly. So it's just a really nice way to add value to your code while you're developing. And as said, it's even useful for monoliths. You don't have to do microservices to do APIs. You really just have to do APIs. Scaling, generally in the cloud, we want to be more like the Zerg. So we want to scale out versus up. So instead of having bigger machines, you generally want to build your applications in a way that scales out. That's where statelessness comes in. So instead of upgrading your machine and having a single big machine, you tend to have a lot of smaller machines. And that kind of goes with the cloud in general, is you tend to swarm things and have swarms of compute units as opposed to having like large monolithic units of compute. Design for evolution. So make sure that you're loosely coupling your services. Make sure you decompose your app when it gets too big. Doesn't have to be microservices. You can build, domain-focused, regular-sized services, and that's fine too. And then, of course, implement automated regression to create a safety net when you're building your changes. We'll talk a little bit more about that in the next section, which is the DevOps tips section. So good DevOps is absolutely essential to building stuff in the cloud. Like, you really have to have a good DevOps situation to be successful in the cloud at all. And the reality is that cloud technology is kind of a subset of the DevOps movement. So really, the reason we have the cloud is to support some of the process capabilities that are part of DevOps. And if you really want to be successful with your cloud infrastructure, you really need to be successful with your DevOps, which to define DevOps is not just a combination of dev and ops. It's really a set of capabilities starting with people, process, and technology that contribute to an overall better organization, better flow of work through the value stream, and just general life improvement for developers. And there's a lot of different things. There's roughly 20 to 25 capabilities that constitute DevOps. And we're not going to talk about all those today because this isn't a DevOps talk, but they kind of fall into three categories. So you have things that involve people. So things like generative organization culture or Western organizational culture, if you've ever heard of that. There's process things like having a streamlined change approval process and not having a lot of paperwork for each individual change to the code base. And then finally, technological practices like using cloud infrastructure, CI/CD, continuous testing, loosely coupling architecture, et cetera. And so what we're going to focus on here in this section is we're going to talk about a lot of technological practices, which isn't to say that the people and process stuff isn't important. It's just not a part of this particular topic. So I'll have some resources at the end if you want to learn more about the other aspects of DevOps, which is something that I'm super interested in general, because there's a high amount of leverage in terms of making things better for pretty much literally everybody involved in your project, from the business to the individual developers. So the first and most important thing that you need to do is you need to automate your builds and releases. You don't have to be in the cloud to do this. You don't have to be using cloud technology to do this. You can 100% do this on-prem. So you really should not be manually putting builds in production or really in any environment. And the thing is, you don't have to go full like continuous integration or continuous deployment. Most companies I work with don't go all the way where everything is automatically integrated and deployed to a production environment. That requires a lot of discipline, but having that build automation in place is really important. And a couple of specific pipelines that are kind of the default on pretty much any project I'm on are going to be your build pipeline that builds your software, a gate pipeline. So whenever you do a pull request into your main repo or whatever the main branch you have is that for your particular sprint, it runs that gate build that runs all of your unit testing, linting, and other forms of automated testing. And then obviously your release for your software. So those are kind of your table stakes pipelines. Nice to haves would include security scans. I generally don't like running those with my gate builds because they tend to take a long time. So I prefer to run those kind of at more of a daily cadence. And then of course, end-to-end regression testing. It's really nice to have smoke testing builds and smoke testing in your pipelines, especially if you want to combine that with your deployment so you can validate whether or not your deployment works by running a smoke test afterwards. So you can kind of go down the rabbit hole of build automation, but this will get you started. Another concept is you want to releasing software is like voting. You should do it early and often. Even if it's hard, the more you do it, the cheaper it will be. So one thing, especially in larger companies, I tend to push teams to try and deploy more often. At a minimum, you want to deploy at the end of every sprint, but ideally, you have automation in place, so it's very easy to build new releases without necessarily even having to wait till the end of a sprint, at least in lower environments. You want to build a bed of automated testing. So there's the whole concept of the automated test pyramid. Obviously, you want to start at the bottom with your unit and your integration tests. But on a lot of projects, I've had value from building API tests. I like to use Postman, which you can actually automate with a NPM package called Newman, which is really nice. End-to-end testing is also nice, but you don't want to necessarily spend a ton of time building end-to-end testing because those tests tend to be brittle and harder to maintain, so there are patterns to mitigate that. And then, of course, adding smoke tests at the end of your releases is also a nice to have, but I like doing it. And of course, performance testing is positive as well. Just as an organizational practice, you want to start trying to shift your security and pretty much everything else as far left as possible. And what that means is kind of the old way of doing things is you build your software and then there's usually some blocker team that runs a bunch of security stuff and then you end up having a bunch of mitigation. It's better to bring that team in the beginning of your project, understand what they're going to want, understand the things that they're going to test, and then build that in earlier so you aren't having to do it all at the end. It's built into your process and you'll probably find ways to automate it and make it easier as you go through your process or go through your projects. Make sure you're using infrastructure as code. This is, you don't necessarily, you can definitely do that while on-prem as well. It doesn't really matter which infrastructure as code language you use. There's a lot of them. The preference at 3Cloud that we seem to run into a lot is Terraform. That seems to be our default infrastructure as code. That I see, and also even on-prem, that tends to be what I've seen on-prem installs where it's usually Terraform. That being said, HashiCorp, the company that makes Terraform, has some licensing shenanigans that they're engaging in, so Terraform may not be the default option forever, but currently that's what we're using. That being said, other forms of ISA are also good and totally valid, but you just want to be using some kind of infrastructure as code and automating the creation of your infrastructure using pipelines. This allows you to treat your infrastructure as cattle, not pets. So you want to make your processes easily disposable. You want to make your machines easily disposable. So fast to start, fast to shut down. That's actually one of the 12 factors we talked about earlier. So you want to avoid resource locks, lengthy pre-caching routines, that sort of thing. You want to make things easy to spin up and shut down, especially if you move to something like Kubernetes or any kind of cloud native infrastructure. That's going to be kind of the name of the game. You're going to have multiple instances, each which individually is going to be disposable, but collectively they'll be highly available. You want your infrastructure to be immutable. What that means is that when you create your infrastructure, you're using code, you're using a script to determine what's in that particular piece of infrastructure. You're running it through a pipeline, and once that is deployed, that infrastructure cannot be changed. We don't want to have people going in and shelling into a server, fiddling with settings, and then piecing out. And the big reason that immutable infrastructure is important is one, for security, but two, to maintain dev prod parity. So you really want your development environments, your QA environments, UAT, et cetera, all the way through prod to have the same configuration. Obviously that doesn't mean the exact same configuration. You're going to have production things, point to production services, et cetera, that sort of thing. And that doesn't mean that your development environments need to have as much firepower or horsepower as your production environments. So in production, you may be running 5 instances and in your dev environment, you run 2. But what it does mean is that each of those things is configured the same way because there's a whole class of bugs that exist from a lack of dev prod parity. And at least experientially in my career, I've been burned multiple different times in multiple different ways based on environments not being configured the same way. So, it's been issues around memcache, scaling that up. I've seen issues around HTTPS versus non-HTTPS, using foldered URLs in your services, using non-foldered file locations. All sorts of things have burned me in teams I've been on by not maintaining this dev prod parity. So it's extremely important for just your general happiness. And finally, an easy way to do most of these things is to adopt the cloud native ecosystem. And what the cloud native ecosystem means is adopting tools like Docker and Kubernetes and using containers and orchestration tools to have your applications be this kind of like. The nice thing about using all the tool sets in the cloud native ecosystem is that a lot of the things we talk about kind of come for free. Like you're going to get your immutable infrastructure, you're going to get your scalability, all these other things come from just adopting the tools in the cloud native ecosystem. If you're curious why there's cartoon characters on this slide, this is if you go to the Cloud Native Computing Foundation website, there is a festive children's book called Phippy and Friends, where they will explain to you how to use the cloud native ecosystem in the children's book format. So if you want to have a good bedtime story for your kids, you can fire that up, and you can hang out with Fippy and Captain Cube and all these other colorful characters. So if you want to learn more about this stuff, probably the best resource that I can offer is the Azure Architecture Center on MS Learn. That one is just absolutely essential. A lot of the slides here will have links to that, to the Architecture Center. They have all sorts of cloud patterns, different practices. So basically, what the folks at Microsoft have done is they've taken all those like 3-inch thick books about writing software, and they've distilled all those into a series of pretty easy to read web pages that talk about building cloud applications. I know that Microsoft is not the only one that's doing this. I know there's a lot of training on the AWS side as well, but I do stuff in Azure, so I don't really pay much attention to, or I don't pay as much attention to the AWS resources, but I know they exist. You can go into 12factor.net. You can read the 12-factor framework. If you want to learn more about DevOps, which is kind of essential to using the cloud, you can check out the DevOps Handbook, which is really good and very tactical. It also talks about the DORA research that shows all of the company-wide advantages of DevOps, where you can have a higher percentage of hitting business objectives. Developers are objectively more happy. They'll refer your company to more people. It's pretty much a win-win, and there's a lot of statistical evidence that shows that. And then finally, if you want to go, another good website to look at for DevOps capabilities is the DORA website, which is actually hosted on Google. So the Google Cloud folks have funded and host the DORA website. So if you want to go out there, you can check that out. It's a very good resource for learning about DevOps. And so I want to leave you with a handful of takeaways for today. One, the cloud ready means it works better everywhere. So by building cloud ready apps, those apps are going to run better in your data center. They're going to be more maintainable, et cetera, et cetera. They're objectively better while also being ready to go to the cloud. Quote unquote, the cloud doesn't necessarily mean public cloud. It's not a company, it's a series of concepts. A lot of these concepts kind of come down to just loose coupling. So make sure you loosely couple your infrastructure dependencies, loosely couple your apps, use abstractions where appropriate, and finally, automate early and often. Builds, releases, tests, try to build as much automation of drudgery as you can in your process. This is going to make your life much easier in the long run. And so with that, go forth and build some cloud-ready apps. Any questions?
So you mentioned Dapper. In a real life project, what was your experience using Dapper, and what sort of application did you build?
So we were looking at Dapper in a couple of different instances. So several of my projects have looked into Dapper. The one that came the closest to fruition, we were building a microservices application that was going to run originally on OpenShift, and then was going to run in Azure. And then humorously enough, in the end, after I left the company and went on another project, they're actually going to run it in AWS now. And that was kind of my initial look into Dapper, is building it into that application so that we could deal with the fact that we were moving from an on-prem hybrid cloud provider to Azure, to AWS, and that it wouldn't matter. We walked down the path a little bit. I'm not sure how far the team got in the end because I left afterwards. We've also looked into Dapper on a couple of other different projects, but Dapper is a relatively new technology, and there are some companies that have adopted it, but I haven't been a part of like a long-running Dapper install yet. So full disclosure there. But it's definitely a technology that should be on your radar. It's supported by Microsoft, and generally something that solves a lot of problems in building cloud native distributed applications.
Cool. Thank you. So one of the techniques that I have used to have such some sort of a hybrid situation is my on-prem. We have Microsoft SQL Server with 3 replicas, and we have a bunch of applications running on-prem. They were initially built for employees, but parts of the application, we are now trying to move it to cloud and offer it as a SaaS platform. And in order to do that, we are basically using the VPN gateway where on-prem and Azure resources can coexist, and we are avoiding going through the internet to keep the latency and other stuff minimum. And I've managed to make that application work as a SaaS by using Azure AD B2C for B2C authentication and authorization. And I've also used effectively the Azure cache services for Redis for state management. So is that like a common strategy, where you're using a VPN, network VPN, to connect to Azure from on-prem, mixing and matching the resources that are available in both places?
That's certainly a way to do it. I've worked on, I've definitely had a handful of clients that'll have on-prem data and then have like an express route or VPN or whatever to shell out to like a shared VNet type of situation. So that is a valid pattern. And then obviously at some point you can migrate your database up, or you can build replication to like a SQL managed instance or something like that, or eventually move into a PaaS service. But yeah, I mean, it's there's definitely situations where you have a hybrid network and the data is on-prem, but the compute is running in the cloud. And there's certain situations too where you have like various filters, and I've heard about companies like just backhauling all of their cloud traffic through their data center. Like obviously there's going to be some latency there, but that is something that I have heard of people doing for their infrastructure.
Cool.
Any other
Again,
questions?
Dustin. Again, great presentation, by the way. As someone that is looking to get into the cloud, what certification would you recommend?
For Azure, there's a series of job-focused or role-focused certifications. The kind of entry-level one is AZ900. So that one's kind of like your general. It's a little salesy. It's not necessarily as technical as folks would prefer, but that is kind of the entry-level Azure certification. There's also AWS equivalents. I don't really know about them because I don't do AWS, but I do know people who are AWS certified, and there's a similar AWS equivalent certification for almost for many of the Azure ones as well. From there, if you want to get certified, it depends on your particular pathway. Generally, there's kind of infrastructure focused certifications, and then there's more like app dev focused ones. So if you're interested in certification, I would explore that personally. My recommendation is just to get test credits and build stuff in the cloud. That's my recommendation. And MS Learn is a good resource as well. So you can get not necessarily free cloud credits by going on MS Learn, but they have like live labs that will use Azure without charging you any money in kind of a limited way. But you can go through and do various lab exercises using those resources.
Okay, thank you.
Any other questions?
So have you used something like change data capture in situations where your database is on-prem, but your full text search engine probably is on Azure. And what sort of tools did you use? If you have done something like that.
I've never had the opportunity to work with any of the full text like service or the full text search services. So I'd probably be a bad person to answer that question.
No worries. Because these are really some of the problems that I'm trying to solve. Now, we have on-prem software which uses a cluster of Elasticsearch nodes. And one of the challenges that we have is indexing the documents, indexing the records that are modified in the relational database and keeping the index, full text index up to date so that, we don't necessarily, when we are doing searching, not miss out things that were recently modified or inserted and so on. And I'm trying to find a solution that would work in a hybrid environment where my Elasticsearch clusters are on in Azure, rather in this case AWS, and the rest of my stuff is on-prem. And it's been quite challenging to find, situations where I cannot. I have to basically write code for everything, and I'm trying to avoid that if possible.
That makes sense. You don't want to have to write a bunch of glue code. Exactly. Yeah, I'm not sure. That would definitely be one I'd have to do some research and think about. Doesn't sound like there's an easy solution to it.
Correct. I've had good success with min.io, which is basically an S3 compatible storage engine that you could run on-prem. And for customers who choose to run it on AWS, they could simply switch it over to S3, and it works perfectly because it's S3 compatible. Now we were using the same AWS S3 client to essentially hook it up with min.io as well as Amazon S3. Those are some of the success stories. I have a lot of struggles, but some success stories here and there.
Welcome to the cloud. There are a lot of benefits, but there's also a lot of complexity.
Correct.
Especially when you have the hybrid situation. Now, one of the nice things or one of the advantages, at least for the last couple of projects I've been on, is that we've had a lot of stuff that's already in the cloud, so we didn't have to deal with as many hybrid situations. So I've been fortunate in that regard, but also unfortunate in that I can't answer your question very well.
No worries.
Any other questions? All right, well, that's good. I'll pass it back to you, Robert, for the closing.
Yeah. All right. Well, Dustin, thank you very much. Thank you, everyone, for attending. I'm going to go ahead and stop the recording.